Hi everyone, I'm Dr. Surjit Singh. Today we'll talk about the Leetcode problem, longest palindromic substring. Let us begin. S is a given non-empty string. We have to find the longest palindromic substring in it. We will use DP to save previous results of the problem. Consider the given string. Its length is 9. We define DP as an n cross n matrix with all entries initialized to false. We define answer with initial value 0, 0. Single character is always a palindrome, so we set all the diagonal values of DP as true. We loop over I from beginning to the second last element of the string and compare it with its next character. If they match, we set corresponding DP as true and change answer to be I plus 1. They do not match in the next iteration, so we skip it. They again match in the last iteration. We set DP and answer for 7, 8. We now repeat it for larger differences. Differences go from 2 to n. Initial difference is 2, in which I goes in the range 0 to n minus diff. J is at position I plus diff. Characters at I and j are not same, so we skip the if statement. In the next iteration, I and j are 1 and 3. This time, the two characters are same and we ensure from DP table that substring between them is also palindromic. DP confirms that the substring from 2 to 2 is a palindrome. This means that the substring from I to j is also a palindrome. We mark 1, 3 as true in DP and save it as the best answer so far. In next iteration, I and j are 2 and 4, but the characters there are different. Same thing in the next iteration. When I and j are 4 and 6, the two characters are same and DP tells that substring 5 to 5 is also palindromic, so we mark ij as true and save it in answer. Next two iterations of I do not produce any change. Loop over I ends. For difference equal to 3, first ij pair is 0, 3. The characters there are both A, but DP tells us that the substring from 1 to 2 is not a palindrome, so we skip it. Same is the case for all ij pairs for difference 3. For difference equal to 4, starting ij are 0, 4, but the characters there are not same even though intermediate substring is palindrome. We ignore this iteration as also the next two iterations. For ij pair of 3, 7, the two characters are same and the intermediate substring is also a palindrome, so we save I and j in DP and answer. No other solution is found for differences 4, 5, 6, 7 and 8. We return substring between 3 and 7, both included as the final answer. In Python ranges, AND value is not part of the output, so we return substring between the range ans 0 to ans 1 plus 1. The last loop is over n, which is present within another loop over n. So time complexity is n squared. DP is an n cross n array, so space complexity is of the order of n squared. In another solution, we take a central character in the string and grow the palindromic substring sideways. Consider the same string. Single character is always a palindrome. To begin with, we consider first character to be the best answer so far. It begins at position 0 and ends at 0. Turn by turn, we try each character of the string to be the middle character of the palindromic substring and try to expand it on both sides. Initial value of mid is 0. We will treat the substrings of odd and even lengths separately. To include neighboring characters of mid, we call the function expand, in which both left and right are equal to mid of the main function. Initial ans is a single character at left, so we save it as 00, 0. Before entering the loop, we ensure that both left and right are within the range of the string and the character at left is same as the character at right, which confirms that the substring from left to right is a palindrome. Inside the loop, we replace old answer with this expanded answer. We decrease left and increase right to expand the search range on both sides. As left goes out of range of the string, we come out of the loop and return the answer to the main function and save it there as new answer. If new answer length is longer than that of the previously saved best answer, we replace best answer with it. This time, however, both the lengths are same, so we do not reassign best answer. If both left and right are equal to mid, expand can give substrings of odd lengths only. To get substrings of even length, we call expand again. This time we pass mid to left and mid plus 1 to right. This forms a pair of characters in the middle. However, we keep the initial answer as 00 because we are yet to establish that characters at left and right are same. After ensuring that both left and right are within the range and both of them have the same character, we save answer as 0, 1 and move left and right away from each other. Left goes out of range, so we come out of the loop without saving the expanded values. We return 0, 1 and save it in the main function as new answer. This time new answer range is longer than the previous best answer, so we save it there as the best answer so far. In this next iteration, mid becomes 1. To find its odd length substrings, we fix both left and right as 1. They both are in range of string and character is A at both left and right, so we save answer as 1, 1 and expand the range both ways. This time character at left is A, but that at right is B, so we come out of the loop, return 1, 1 and save it as the new answer in the main function. Its length is one character, while the best answer that we already have has two characters, so we do not save it in answer. For solution of even length, we call expand for left equal to 1 and right equal to 2. However, we keep this initial answer as 1, 1. As characters at left and right are different, we do not enter into the loop and return 1, 1 and save it as the new answer in the main function. We discard this as we already have a better answer. Next mid value is 2. We call expand for 2, 2 to get odd length palindromic substrings with center at character 2. Its initial answer is 2, 2. We expand the range in the next iteration. The characters at left and right are same, so this is also palindromic, so we save this as revised answer. In the next iteration, left and right becomes 0 and 4, but this expanded substring is not palindromic, so we do not save it and come out of the loop. We return 1, 3 and save it as new answer in the main function. This answer is longer than the answer we previously have, so this new answer is saved as the best answer. For even sized answer, we send 2, 3 to expand but keep initial answer as 2, 2. As the character at left and right are different, we do not enter into the loop. The answer that the function expand gives us is 2, 2, and we save it as the new answer in the main function, but discard it there as it is smaller in length than the best answer we already have. Now mid becomes 3. Its search for solution for odd length proceeds like this, and it fails here. New answer becomes 3, 3, but we discard it. The even solution does not even enter the loop. Next, we take up mid equal to 4. Its odd and even solutions both give answer as 4, 4, and we discard both of them. Now we take up odd solution for mid equal to 5. It expands as this and then as this. In the next iteration, characters at left and right are different, so we come out of the loop, return 3, 7, and save it as new answer in the main function. It is by far the best answer, and we replace the previous best answer with this. Remaining values of mid are 6, 7, and 8. None of these gives a longer palindromic substring. We return the best answer. Substring range of this is for 3 to 8 because in Python range end value is not included as part of the substring. The main function has a loop that is linear in n. Expand function will have maximum n by 2 iterations. Practically, the expand function iterations will be much less than this, but in the worst case, the time complexity is of the order of n squared. We do not save the substrings anywhere, so space complexity is constant. Thank you for your time. I hope you liked the video. Please stay tuned for more such interesting videos.